My title? Okay. My name is Randy West. I'm the director of the National Center for Asphalt Technology at Auburn University.
And so over the course of this series, and we're doing videos in conjunction with NAPA for Federal Highway. Series of 3 videos. We've got a video on density and durability, a video on smoothness, and then a video on long life pavements. But before we get into that, I'd like to just ask you a question, and you tell me why choose asphalt as a paving material?
Yeah. Asphalt's, it does have some advantages in terms of its durability, its smoothness, recyclability. I just like to ride on asphalt because of the smoothness. It's quiet. It's recyclable. We can continue to resurface the roadway and keep it in good condition for the driving public.
And also, before we get into some of these, I'd like you maybe to tell me a little bit about the capabilities that NCAT has, and what does that mean to the transportation industry?
Well, NCAT was established to do research, practical research for the industry, and so it gives us a chance to interact with the industry, to address needs that the industry has, to make innovations, to try to make the product better, asphalt pavements better, longer lasting, smoother, quieter, less rolling resistance is another kind of hot topic right now. So it's really, NCAT's capabilities are pretty broad. We're able to look at a lot of different issues, whether it's a mixed design issue in a laboratory or evaluate things on the test track. Such a great asset for us to be able to use that as a proving ground for technologies. And we're also very comfortable with getting out in the field, working on projects like the density project, working with contractors and state agencies all over the country, really to evaluate, what we need to be doing to make pavements last longer.
Oh, that's good. So with the partnership capabilities that NCAT has and the partnerships that you work with, what does that ultimately mean to the driving public?
Well, it means a good value for their tax dollars. That is exactly what we're trying to do, is to make sure that the investments that are made in our highway infrastructure, our pavements, brings the best value for that tax dollar. So we take very seriously, our job of trying to make a product, and that it's not only just research in the laboratory, but it also involves getting out and sharing that information with the stakeholders through training classes, through education, workshops, through printed material, through media outlets. So there's lots of different ways to kind of get that information out there so that it can be used, can be implemented, and make a better value for the public.
So, a lot of the research and work that you've done at NCAT has borne out some very specific relationships, I think, between density, durability, and performance. Can you talk about that?
Well, we've done a number of different things through the years looking at the impact of density on pavement performance. It's something that I think most pavement engineers understand, that relationship. We've tried to find some data based on test track information, but also looking to gather information from projects around the country. We're actually working on that now, working on some projects around the country where we try to work with contractors to reach higher density levels, and so that we can follow those projects and see what the impact in performance is. We've also got another study that is looking at existing data, LTPP data, to try to understand the relationship between air voids or in-place density and the performance of those pavements. So we're looking at it in every way that we can, with historical data, gathering new data, real projects, as well as on the test track. We've done some laboratory work as well, but I think the real proof to me as a pavement engineer is what we see in the field.
What are some critical things that contractors need to do in their construction practices to ensure proper density?
It really starts with mix design. There's a lot of things that we can do to make mixes more compactable. There's a lot of things in terms of production control and consistency of the mix. A lot of density is also affected by the lift thickness, making sure that we have the right thickness for the aggregate size that's being used in the mixture. And then it comes down to good paving practices and good compaction practices by the contractor to make sure that they are using a good rolling pattern, that they understand how many passes it takes with the rolling train that they have to reach the highest level of density they can. In some regard, it also gets back to the specifications and the agency's requirements for quality assurance on density. Every agency has density as a quality assurance pay item. So contractors know that that's an important issue. I think we're looking at whether or not we should raise that density target, the minimum density, up for some mixes to try to improve the durability. But it takes all those aspects, from mix design to production, paving operations, to really achieve what we're trying to accomplish with higher density.
Very well said, and you knocked out already several questions with that one answer.
Okay.
So well done there. Let me ask you this though, well, you might have with mixed design. I had a question that said, what are critical things that DOTs need to consider to ensure optimal density? But I think you hit that with the mixed design. Was there any element of that you wanted to revisit?
Okay, let me think back through that. In the laboratory, there really aren't tests that we utilize on a routine basis for evaluating the compactability of mixes. There have been a number of studies that have looked at ways to evaluate that. We did that at NCAT. There are certainly some indicators in some of the compactive effort processes that we use in the laboratory that can provide some indicators of the compactability. But there's also things that just knowing through experience what gradations work, what aggregate types work together in terms of compactability, that really comes through experience that are very important. And I think the agencies, in terms of their specifications, not only there's kind of three parts of this. There's the mixed design criteria, and I think that in some places, the mixed designs have tended to make it such that the contractors had to use gradations that were hard to compact. And we've learned through the last maybe 2 decades that sometimes, even though it's a good strong mix for rutting resistant, it's a hard mix to compact. And so we've learned some things to do in terms of the laboratory research, and we've adapted, I guess, our mix design specifications to look at gyration levels, to look at asphalt contents, to even look at the gradations that we use to make mixes more compactable in the field. There's also a component that, as I mentioned before, that looks at the thickness. This is also generally controlled by the project specifications. We know that mixes, in order to be compactable on the roadway, we need at least 3 times the nominal maximum aggregate size to be able to reach a good compaction level, a good density level. In reality, we ought to be really targeting 4 times the nominal maximum aggregate size in order to get a good density level. A lot of times we're trying to place mixes too thin, and that is affecting our ability to get density. And the third level, not level, but the third part of that is the specifications and making sure that we are getting a good target density, not just in the mat, and we measure density, with the right type of equipment, that we're making sure that density is uniform across the mat. There's technologies available to us these days with intelligent compaction to make sure we've got good coverage of the rollers across the mat. Infrared technologies that give us a good sense of temperature uniformity because temperature is a big factor in the ability of contractors to reach that density, and how they attack the density at the joints. And joints are often one of the key areas where we have issues with performance. And we need to pay a lot more attention sometimes to that joint in order to assure durability.
Now,
hopefully in all of that, I know I stumbled through a lot of different things, but you can maybe pull out two sentences or two words out of that.
Definitely, even more, way more than that. So Dr. West, obviously the industry is one that's always wanting to further itself and offer better roads, better product to the user and to the owners, as evident here by this conference with folks gathered from different aspects of the industry. But going from the lab or the field, where you're having certain things borne out, maybe relating to density and durability, maybe relating to other aspects, how do you get that? Is it a challenge to communicate that to the producers out there? And if so, how do you mitigate that?
Yeah, there's always a challenge in getting the right information to the users. That is certainly as important as doing good research is trying to figure out ways to get that information to the stakeholders, to the contractors, to the agencies. There are a number of ways that we have to do that. We do our own training classes through NCAT. We work with several agencies to do certification classes for paving technicians, for paving crews. Those are very important in order to get that information, and it's got to be done continuously. It's not something we can just do a course this year and then we're good, because of the turnover that we have in the industry. The natural turnover that we have requires that we continue to do that. And technologies change. We do have new technologies like intelligent compaction, like infrared technologies, and those need to be shared as those develop and get put into mainstream practice. So it's just got to be a continuous effort in terms of training. All the DOTs have technician certification programs for mixed design, for quality control, and most of them also have some type of certification program for paving operations as well.
That's good. That's good. Can you talk about the use of recycled asphalt materials and how does it affect density?
Well, we've been working on using recycled asphalt for a long time, and this industry has a good track record of being very sustainable in terms of recycling practices. But there's always an opportunity to improve that and to actually use higher recycled contents. There are a number of materials that we recycle, but the number one material is always going to be recycling asphalt pavement back into new mixes. Recycling in terms of asphalt may affect the compactability a little bit. Usually it's not really noticeable in terms of the measurements that we do in the laboratory or in the field. There are other things that we do in terms of mix changes that probably have more significant effects than recycling on density. Okay, but I'm not saying that it's not there. There are some minor effects of recycling. I may be saying things that are different than what other people say, but what we've looked at is that RAP in itself has a fairly insignificant effect on density. And you can look at data that we've collected from projects around the country through the years where we've done higher RAP contents compared to kind of more nominal RAP contents and looked at the density levels. And with the same compactive effort, we've seen that we've been able to achieve the kind of density levels that we're shooting for. There's also cases of other countries using much higher RAP contents. The Netherlands, Japan, typically we use 40–50% RAP in mixes, in some cases even higher than that. And they've been able to achieve very good density levels. You do have to treat those types of mixes with very high wrap contents differently. There may be other things that we have to do with the materials in the mix design to get that high of a wrap content to work from the mix design point of view. We may have to add recycling agents or rejuvenators or softer binders to counteract the older, aged, stiffer binders in the wrap. But when we do follow those well-known, well-established mix design practices, we don't see any issues with using higher wrap and getting good densities.
That's good. Good response. No. What about warm mix asphalt?
Yeah, warm mix asphalt really took off over the last decade or so, and it's been remarkable to see how quickly the industry has adapted warm mix technologies to the everyday mainstream practices. And I think that the main motivation to using warm mix technologies in the United States has been as a compaction aid, as a way to improve the compactability of mixes, to improve perhaps paving in a little bit cooler weather, so extended paving seasons. It's also helped in terms of maybe some longer haul distances. So that's one of the key benefits that contractors will say that warm mix brings to the industry. Originally, warm mix technologies were brought to help kind of address environmental concerns, to reduce temperatures, reduce oxidation, reduce emissions with plants. But I think the real benefit that we've seen in the U.S. has been on the compaction side.
That's good. That's good. Would you say, are there any changes to pavement design or asphalt mixture design that would make achieving consistent density easier for paving contractors?
I think the key thing with regard to pavement design that affects density gets back to that lift thickness, to the nominal maximum aggregate size used in the mix design. We have to have that 3:1 or 4:1 ratio on the thickness to the nominal maximum aggregate size. And that's an agency set issue, and the contractor has some flexibility in terms of mix selection for the thicknesses that are used in the overall pavement structure or in an overlay.
How does, you already mentioned intelligent compaction, but can you talk about the role of technology in density and durability?
Well, I think the manufacturers of the rollers, the original equipment manufacturers, have done a great job of improving their machinery to achieve higher density. 20 years ago, we were talking about impact spacing to get the impact spacing up to a higher number so that we're able to achieve a higher level of density. So that was looking at changing mechanical forces to achieve that density with a higher frequency that they use in the drums. But that's one example of, I think, technology that was adapted or modified or that advanced 20 years ago. I think right now the technology that is moving forward is intelligent compaction. And there are different aspects of intelligent compaction, but the primary aspect of intelligent compaction that benefits the asphalt industry is just making sure that we've got good coverage of the mat with the rollers. We've got the right number of passes with the rollers to make sure that we've got that full mat covered with the rolling pattern that we have.
That's good. Are you able to talk about Beta 5?
I don't know that well enough to talk about it.
Okay. Let me then ask you this question. This is about intelligent compaction. Tell me about the potential future use of intelligent compaction. Where's it headed?
Well, right now I think that the intelligent compaction is really in the hands of the contractor. Their choice to use it or not use it, and whether or not they really embrace that technology is kind of their control. And I know that some contractors have have really taken on this way to improve their operations, to be more efficient in their operations, to make sure that they are achieving the density levels in a uniform way. I don't think that the agencies are necessarily going to specify intelligent compaction, and perhaps that's the right approach, is let the contractors determine which technology works for them, and they can then be more efficient or figure out which processes to utilize to achieve the target of density that we're trying to achieve.
Great. Moving on to the topic of smoothness.
Okay.
I wonder if you could talk a little bit about some of the work that you've done in NCAT in studying and achieving different smoothness values, and then talk about then how smoothness affects performance overall.
Yeah. I wouldn't say we've done a lot in terms of smoothness through the years. We've certainly pay attention to smoothness as a key factor. Agencies now look at smoothness not only as a pay factor for the contractors, but also in terms of the performance of pavement, looking at IRI. We haven't done too much in terms of trying to figure out how to improve smoothness, with the exception of perhaps one thing, and that is utilization of remixing technologies, if you will, the transfer vehicles that allow you to bring mix, to the paving operation, to the paver, transfer that mix into the paver without slowing the paver down. We do know that it helps improve smoothness. It also keeps the paving train moving at a more uniform speed, and so uniformity in terms of temperature is also a factor of that. And we've looked at the effect that those material transfer vehicles have on things like density in the short term. We really haven't looked at those in terms of long-term improvements, long-term durability, or long-term payoff in terms of smoothness. On the test track, our sections are so small that we really can't really look at smoothness as a key part of the research there. So it gets back to just a few field projects that we've been involved in through the years on smoothness.
So talk about how smoothness is used or should be used in pavement design.
In pavement design. That one's kind of outside of where I would be comfortable talking about.
Okay.
Yeah.
Okay. What about the expectation of smoothness? Is it independent? Should the expectation of smoothness be independent of pavement material type?
I think mixes, the selection of mixes does affect smoothness in some degree. Some mixes are obviously going to be easier to compact and easier to produce a smooth pavement. Generally, the finer maximum aggregate sizes mixes can produce smoothness. But we've also seen mixes like open graded friction cores provide really good smoothness numbers. But smoothness, I think, is more affected by the paving operations and the contractor's operations more so than the mix design.
So how does smoothness affect dynamic loading?
Well, from an engineering point of view, I think that, obviously a rougher pavement is going to cause the vehicle to have, more bouncing around on the pavement, creating more dynamic loads on the pavement, which would therefore drive, issues like higher stresses that lead to pavement damage. Other than that, I don't really have any data to kind of support that.
Can you talk about how does smoothness correlate with future rehabilitation needs?
Smoothness is one of the key parameters that states use to decide, when a pavement needs rehabilitation. Use an IRI. Okay, so there's different thresholds that different states will use for evaluating pavement condition. Rutting, cracking, and smoothness. So it will continue to be a key parameter in terms of determining when a pavement needs to be resurfaced, overlaid, or if it's concrete pavement, for example, diamond grinding is often driven by, kind of that IRI number.
For my benefit, can you tell me how is IRI measured? What's the process by
Yeah, I'm
measuring
gonna
it?
pass on that one too, because I think there's other people that can do a better job of explaining that than I do.
Yeah.
Okay.
Okay, that's fair enough. So, I mean, is it, well, I guess, we saw on the concrete side of the house, some real-time smoothness, apparatus that was attached to, like, say, a concrete paver. And it used a ProVal software,
Okay.
created by Federal Highway.
Okay.
And I know ProVal is available, you can input any kind of data in that, so.
Right.
That maybe that's one of many things. So
Yeah.
that's not, I don't want to give us away from the topic. So what factors affect smoothness?
The factors that affect smoothness, I'm going to give that a little thought before I kind of jump into it. Smoothness is just not one of those areas that I got a lot of good background. BuzzPal, for example, is probably a much better resource on that, because he's dealt with using profilers on the track, certification of profilers to measure smoothness. I think one of the key issues for smoothness is just uniform operations in terms of the paving train, not stopping and starting the paver. So that gets back to scheduling, making sure the equipment's in good working order before they begin, and keeping that paving train moving at a uniform rate. Gets back to the material transfer vehicle that we utilize to transfer mix from trucks into the paver. Those, to me, I think, are some of the key issues or the key factors that affect smoothness.
That's good. Are you able to talk about MAP 21?
Probably not. I probably would be incorrect if I tried to say too much about MAP 21, about the performance criteria. Is that what you're talking about?
Right.
Yeah.
Okay. So moving on then to long life pavements. Can you talk about, we're about to run out of card on this. Okay. How much more time?
No, it's on the slides.